Okay, so this problem says that we're pushing a broom which weighs 15.1 newtons and exerting a force of 26.2 newtons down along the handle, which makes an angle of theta with a horizontal. And we know that the broom moves at a constant speed because it's given to us in the problem. We also know that the force of friction is 13.5 because it's given to us in the problem. And so we're going to be pushing the broom towards our right, and the force of friction will be acting towards the left. I'm going to put in my normal force here, and then the y component of that push of that broom, because there's going to always be an x and a y component to the force. It tells us that that it's moving at a constant speed, so we know that the acceleration is going to be 0. So I'm going to go ahead and determine that I need to use cosine. And I'm doing this because we know that we need to find, for part A, the angle. And to do that, the two components of the triangle that we have are the adjacent side and the hypotenuse. And so cosine is adjacent over hypotenuse. So I'm going to plug in my values here, and then I'm going to take the inverse cosine to get theta by itself, so that we can solve for theta, or our missing angle. So once we plug everything into our calculator, making sure our calculator is in degrees, not radians, we're going to get 59 degrees. Okay, for part B, we're going to find the normal force. And so we'll remember that the normal force is the force of the surface pushing up on that object. So we're going to have to involve both the weight and the y component of that push on our broom. We have to include both of those because both of these forces are involved in that vertical direction. So to find the Fy component, I'm going to use sine because we need to find the opposite over the hypotenuse. And so I took the opposite, which is Fy, and the hypotenuse, which is 26.2, and then I cross-multiplied to solve for Fy, and that gave me a value of 22.5 newtons. So I'm going to plug that into my equation for the normal force, and that gives me about 37.6 newtons. Okay, for part C, it asks us to find the coefficient of friction. This will be pretty simple since we found a lot of the other things that we'll need for this. We already found the normal force, and we know the force of friction because it was given to us in the problem to be 13.5. So we're going to plug that in, plug in the normal force that we calculated in part B, and then just rearrange the equation to solve for mu to be 0.36.